Good day, students. Welcome to Grade 10 Science, and I am your teacher, Sir Raymond Balansay. Today's lesson is Plate Tectonics Theory. Have you ever wondered why Earth's land masses look like pieces of a giant jigsaw puzzle? Notice how South America and Africa appear to fit together. About 200 million years ago, all of Earth's land was connected in a supercontinent called Pangaea, Pangaea, or Pangaea. One great ocean surrounded the land. Then about 80 million years later, the land started to break apart and the Atlantic Ocean began to form. By studying the ocean floors, scientists were able to support the theory that all the land masses on Earth were once connected. Today, scientists have gathered evidences to support this theory. Our country is blessed with so many land features such as mountains and volcanoes. These features can be sources of different minerals or can be used for agricultural purposes. For example, we have the majestic and the world-renowned Mayon volcano. Because of its activity, it produces fertile slopes and plains which are used by the locals to grow their crops. Also, found in the northeastern coast of Luzon, we have the Sierra Madre mountain ranges, which is home to many endemic species of flora and fauna. Have you ever wondered why our country is endowed with this kind of geologic features? Well, if your answer is yes, then this module will help you find the answer to your question. In this module, we will study thoroughly the framework that will enable us to understand how and why several features of the Earth continuously change. This theory is what we call plate tectonics. This describes the events within the Earth that give rise to mountain ranges, volcanoes, earthquake belts, and other features of the Earth's surface. At the end of this module, you are expected to answer the key question. From the deepest ocean trench to the tallest mountain, plate tectonics explains the features and movement of Earth's surface in the present and the past. What is plate tectonics? Earth's lithosphere consists of layers, the crust, and the upper part of the mantle. The crust is made up of a variety of solid rocks like sedimentary, metamorphic, and igneous. It has an average density of 2.8 grams per cubic centimeters, and its thickness ranges from 5 to 50 kilometers. The crust is thickest in the part where the relatively young mountain is present and thinnest along the ocean floor. There are two kinds of crust, the thicker but less dense continental crust and the oceanic crust, which is relatively thinner but denser than continental crust. Earth's surface is made up of moving, solid pieces called plates. Plate tectonics is the study of the formation and movement of these plates. The Earth's crust is divided into major plates, which are moved in various directions. This plate motion causes them to collide, pull apart, or scrape against each other. Each type of interaction causes a characteristic set of Earth's structure or tectonic features. The word tectonic refers to the deformation of the Earth as a consequence of plate interaction. The border between two tectonic plates is called a boundary. The plate tectonics theory suggests that the Earth's crust is made up of plates that interact in various ways, producing geologic events such as formation of mountains, volcanoes, trenches, and the occurrence of earthquakes, volcanic eruptions, and tsunamis. Developed from the 1950s through the 1970s, plate tectonics is the modern version of continental drift, a theory first proposed by scientist Alfred Wegener in 1912. Wegener didn't have an explanation for how continents could move around the planet, but researchers do now. And according to Nicolas van der Els, A seismologist at Columbia University in Palisades, New York, plate tectonics theory is the unifying theory of geology. And that concludes our discussions to today's lesson. Watch out for our next video lesson. Class dismissed. Thank you and mabuhay.